Alright, in this recording we're going to look at the questions on the exam about algorithms. The algorithms that we talked about you needing to know is selection sort, conversion between the different bases, that's the same as the first exam, determining whether a number is prime, and the encryption that we did. For each one, all you need to be able to do is to run the algorithm on a small example. Here are some examples here. First is the prime number 1. So I'm just going to take some notes in a file, kind of like you would do on your paper. The first question is the number 31 prime? How can you tell if it's prime? So you wouldn't have to write this on your paper, but it is prime if it doesn't have any even divisors other than itself. And 1. Okay, so something that you should know to make this easier, if 31 is not prime, then it has a divisor at most the square root of 31. Okay, what's the square root of 31? 5 point something. Okay, because 6 squared is 36. Alright, so what we need to do is we need to test 31 over 2, 31 over 3, 31 over 4, 31 over 5. If you want to, just to be safe, test 31 over 6. Okay, so 31 over 2 is 15 with remainder 1. 31 over 3 is 10 with remainder 1. 31 over 4 is 7 with remainder 3. 31 over 5 is 6 with remainder 1. And 31 over 6 is 5 with remainder 1. Okay, so each one, there's no even divisors. 31 is prime. Let's take a look at 33. That was the next one given here. So is 33 prime? We would test 33 over 2, 33 over 3, 33 over 4, 33 over 5, 33 over 6. Alright, 33 over 2 is 16 with remainder 1. 33 over 3 is 11 with remainder 0. Okay, so 33 is equal to 3 times 11, so 33 is not prime. Alright, this is the algorithm. You just try dividing each number. If you ever get one with a remainder of 0, then you know you're not prime. You only have to go up to the square root of the number. Alright, that's the algorithm for testing if a number is prime. Second example is converting between binary and hexadecimal and decimal. This is just one way that you could go. So convert 1100, 1100 to hexadecimal. That's the easy one, because all you do is group them in 4 bits at a time, and 4 bits of binary is 1 digit of hexadecimal. This one here, if you're going to view this as a 4-bit number, this is the 1's digit, 1's bit, 2's bit, 4's bit, 8's bit. So that's 8 plus 4. What's the hex, which is the same as 12? And what's the hex digit for 12? It's 3 more than 9. That's C. And the second one is also C. Okay? If you're going to convert 1100, 1100 to decimal, then you just want to add up what each of these bits is worth. The one on the right here is worth 1. Next one over is worth 2. Next one over that is worth 4. And then 8. Okay, so that's those 4 bits. And then you just keep going up by powers of 2. That's what each bit would be worth. And what do we have? We have 1, 1, that's 128 and 64. And then you have the first two bits here is 8 and 4. And whatever that equals. Same type of thing we did on the first test. All right, next example is doing a encryption. If you have the word good, you want to encrypt it with a Caesar cipher by shifting each letter by 4. Good with Caesar cipher. Password is 4. Let's just write out the alphabet. All right, there's the alphabet. We're doing good. If you're going to go over by 1, 2, 3, 4, you get a K. On your paper, you could write something like an arrow going from H-I-J, going from G to K, just to remember that. All right, so G goes to K, O goes to S, D goes to H. So this would be your answer. The other way is decrypting. I'm going to decrypt the message QEPQ. QEPQ. It was encrypted by the password 23. That means every letter was shifted over by 23. Was shifted right by 23. This means A would have gone to, if you count it out, you get X, because Z would be 25, and Y would be shifted by 24. So X is 23. The other way that you could get to X is by going left by 2. Left by 1 from A is Z. Left by 2 from A is Y. Wait a minute. Each letter was shifted right by 23, or same as shifting left by, it should be 3. So let's see. A, if you were going to write these out, if A is 0, B is 1, you would get up to Z being 25. So if you shift by 25, you would get to Z. If you shift by 24, you would get to Y. If you shift by 23, you would get to X. Going the other way, yeah, same as shifting left by 2. Okay, so that was for the encryption phase. Now to decrypt, do the opposite of encrypting. Okay, so that means we either go left by 23 or go right by 2. Which one's easier? Probably go right by 2. Let's see, we have Q to start off with. Let's go right by 2. I'm sorry, this is same as shifting left by 3. We're going to X, not to Y. If you're at A, right, and 3 plus 26, 23 is 26. So if you're at A, you go Z, Y, X. That's left by 3. All right. So we're at Q. We want to go right by 3, that's T. We're at E, right by 3 is H. P, right by 3 is S. Q, right by 3 is T again. Yeah, I think there was some kind of mistake. That's not a real word. Okay, but that is what it is for that. All right. Next question is showing what happens with selection sort. If we have this list of numbers, selection sort on this list of numbers. Remember, so this is what the list looks like as we go through the algorithm. I don't want to just see the final sorted list because that's easy. Show me what steps it goes through. Okay, so first it's going to find the smallest, which is 0, and swap it with the one at the beginning. So 0 will go there, and the 3 will go at the 0 spot. Next, you'll find the next smallest, and we'll go here. It's already there. Next step, find the third smallest to 2 and swap that. And you just keep going from there. 3 goes next. Swap it with the 7. Next would be the 4. Swap it with the 8. And now everything's in order. If you want to, you could copy and paste another, you could write down another step, but they're already sorted. So you would write something like this. All right, that's it for the algorithms. Those are the algorithms you're supposed to know, and all you have to do is be able to run them on paper and show your work. If you don't show your work, you don't get credit. Because these are simple enough that you could sort of figure them out in your head. What we want to see is that you know how to use the algorithm. And that's the end of this video.